Okay, so let's go ahead now that we know that our base is 6 plus x, because it would make no sense if we had a triangle that wasn't using all of this part. So we've got area equals 1/2 6 plus x, 36 minus x squared. Okay, so we're going to FOIL. And then I'll do the 1/2 at the end. So 6 times 36 is 216 minus 6x squared plus 36x minus x cubed. And then take half of that. So a equals, well, half of 216 is 108 minus 3x squared plus 18x minus 1/2 x cubed. All right, so we want to go ahead and maximize. So we're going to take the derivative. So 0, I'll say a prime, nothing. So minus 6x plus 18 minus 3/2 x squared. Okay, we need to set this equal to 0 and I put these terms in order. Okay, I'm going to get rid of the fraction by multiplying everything by 2, even the 0. So 0 equals negative 3x squared minus 12x plus 36. And then I could actually divide everything by negative 3 to make this easier to solve. So negative 3, negative 3, and negative 3. And then quadratic formula or factoring. I'm a factoring fan. So 0 equals the factors of 12 that give me 4 are 6 times 2. To get positive 4, I need positive 6 and negative 2. So 0 product property. So x equals negative 6 or x equals 2. Now, remember what x was, though. X was just this region. So if I have negative 6, that doesn't make any sense, okay? So this x needs to be 2. So if x is 2, though, that makes our base 8, because it's that 6 plus that 2. So our base is equal to 8, and to get our height, remember, we're going to plug in our x value. X, though, starts from 0 to where we went, so x is still 2. So 32 minus 2 squared, which is 4. 36 minus 4 is 32. So the area of our triangle is 1/2 base times height. So half of 8 is 4 times 32 is 128 for our area. Yay! This is some pretty intense math, I know. I think it's super fun because look at all that work. It's so satisfying. Okay. All right, number 6. Find 2 non-negative, so if we get negatives, that's just a restriction, whose sum is 75 and the value of x times y squared is as large as possible. So we want to maximize that value. So this is going to be another system. So I have 2 numbers that have to add up to be 75, just because they say so. And then I know I want to maximize the value, I don't want to use y, x times y squared. So this is what, because I want to maximize, that's what I want to take the derivative of. But we never want to use 2 variables. So once again, you can pick. I can solve my first equation for x or y and then do substitution. I kind of look at this and I don't want to FOIL anything out because, well, I'm lazy. So I want to get x by itself so I can get rid of it. So x equals 75 minus y. So our value is equal to, that's x, times y squared. Okay, this is still the original. So distribute. I mean, you got to pick your battles. I don't really like to do that much work if I don't have to. But I'm not scared of it. So now we want to maximize that value. So v prime and y is our variable. So multiply 150y minus 3y squared. And because we want to maximize, we set it equal to 0. And then we want to do some factoring. Never divide by y. That does get rid of one of your possible solutions. And endpoints do count. So always do factoring. So we can factor out a 3y. So 50 minus y, and then set them equal to 0. So y could equal 0. There's no restraint, and I'll show you. And then add y. So y equals 50. So these are my two possible scenarios. So if I have my numbers, and I'm just going to organize it. So if I have, let's say 0. So if I have y equals 0, well, they have to add up to be 75. So that means that x is equal to 75. Okay, and that could be possible. So if I do x times y squared, I have to check. Well, here's x times y squared, which gives me 0. That's probably a minimum, okay? But they could have asked for that. So that's how I would get a minimum value. And then my second scenario is, what if y is equal to 50? So that means that if y is 50, that x is 25. And so I get 25 times 50 squared. Well, obviously that one's going to be larger. So they just said to find the numbers. I don't even have to actually find the value. I just know that it's larger. So I would say x equals 25, y equals 50. But what would we get? 2,500 times 25. I know 25 times 25 is 625 with 2 zeros. Okay, so I would have a minimum value and a maximum value. Okay, so don't always discard 0. It really depends on the scenario. All right, last one. This is the classic open box problem in calculus. Not for the AP exam, but just calculus in general, because you really are trying to use math to apply it. So like when companies are trying to do their packaging, they're trying to minimize cost, maximize the volume of cereal they can put in a box, stuff like that. So this is actually pretty applicable. People use this. Sometimes they don't always use the results, but that's a whole other discussion. So if we have a rectangular sheet of paper, you want to think of it like this. Okay. And this is 20 by 12. So I'm going to make that 12 inches, and this is 20. Okay. And what they want to do is they want to cut these corners off, because fold them, because if you bring these up, what happens is you end up with, let's go ahead and draw these in. You end up with a smaller region, but those boxes are what actually end up folding up. I gotta draw it like this. I'm a terrible 3D drawer. Let's do it like that. And so this would have been like what we cut off right here for each corner. And then these sides fold up. Does that make sense? Okay. Okay. So we want to cut off squares so it folds into an open top box, kind of like a lid. What should the length of the corners be cut off in order to maximize the volume of the box? So because these are squares, we're going to let these be x. Okay, so these are going to be cut off. So our box that remains, and I'll just draw like this, is going to be volume equals length times width times height. So let's think about this. Well, if I'm cutting this off, then this would now be what the sides are. So this is going to be x, okay? This side is all that's going to be left on the real box, which is 12 minus 2 x's, okay? So I can think of that as 12 minus 2x. And then this height, like length, whatever, is going to be this side, which is 20 minus 2x. Does that make sense? So our volume is length times width. And this really only works if they're squares, so they're always squares. Okay? So now I got to do some math because we can't do a triple product rule. I could distribute an x to one of them and then do a double product rule, but I'm just going to multiply this all out. So I get 12 times 20 is 240 minus 40x minus 24x and then plus 4x squared times x. So our volume is 240x. Let's see, that would be negative 64x times x. And then that times that. And I'm not even putting them in order because honestly, we don't care. So if I want to maximize that, we're going to take our derivative. So 240 minus 128 plus 12x squared. And then they actually tell us that we need a calculator. So I can reduce this, but if I'm going to use a calculator anyway, we want to know when this equals 0. So you have some choices. Okay. One, you could do the quadratic formula because you're given a calculator. And all I want to know is how long the lengths of the corner should be. And guess what? That's what x is. Okay. So you could do the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. But I never do that because I'm given a calculator. So you want to graph it. And when it's set equal to 0, you want to do the roots. Okay, so I'm going to try to bring this up and show you on my screen. Okay, so in y equals, I went ahead and put in the equation. Notice I didn't change it. So now we're going to hit graph, and we'll probably have to mess with our window. Ooh, we don't. So what we want to know is where it equals 0. So we're looking right here, and we're looking right there. Okay, so we have two values. So we're going to go to second. We want that calc, so hit second trace, and we want the 0 function. Okay, so this is something you have to be able to do. So I'm going to find this one first. Your cursor, because this is so large, it's going to be a little hard to find. So you're going to use the left and right arrow. Left bound means I need to pick a point to the left of where I think it crosses. So I'm going to move my cursor. It's right now at 0. So I'm going to move my cursor to the right until I see it. I just go slow because I know it's after 2. Right there. Okay, well, that's as close as I can get. Okay, so I'm going to hit enter. Then I have to move it to the right. So I'm going to go one notch there. And notice it's off my window. That's okay. Hit enter. And then hit enter again. Okay, and it found it. So I know one of them's at 2.43. Okay, so write that down. We would need 3 decimal places. So 2.427. You can just chop it off. Now, I'm also going to find the other one, though. So we're going to do it again. So second calc, and we want the 0. And so now here's where I think it is. So the left is actually going to be down here, which is at what? 1, 2, 3, 4, 5, 6, 7, 8. So it's after 8. So I'm going to keep moving to the right till I get closer to 8. And I see my curve, my cursor. I'll probably only see it once. Okay, right there. So let's see. Okay, so there we are. So that's to the left. So I'm going to hit enter. Then I need to go to the right. So you have to give it a window to work on. So I'm going to move my cursor and I'm going to hit enter. And then I just hit enter again and it tells me my answer. So 8.239. Okay. All right, so let's go back to our paper. Okay, and so I ended up with either x equals 2.427 or x equals 8.239. Well, let's see if this makes sense. If my paper has to be 12 inches this way, if I took off 8 and 8 here, that wouldn't work. Okay, so that means that that is the value that would maximize the volume. Okay, so in calculus, if you can't use your graphing calculator to solve an equation, please email me and we need to go over that because that will be a skill that you're expected to do. Okay, and it also saves time. Calculus, AP Calculus, it's 3 minimum. I just chop them off or you can round, they don't care. All right, well, that's 7 problems, which should give you a good start. You try your practice and good luck.